Hello friends, welcome back to my channel Learning Physics with Bhavya ma'am. PU board has released 3 model paper in all subjects and already I have uploaded MCQ and filling the blanks in my channel. So today we are going to discuss numericals of model paper 1. If you go through all 3 model papers, you can see that the first question, 42 question, is always comes from first and second chapter in electrostatics. That is either from electric charges and fields or from electrostatic potential and capacitance. So if you have to be thorough with these two chapters, numericals. Electric field and electric force is there, so both are vector quantity. Okay, so I've solved some numericals in that. You just go through my channel, you can see some numericals in first chapters. Okay, and in second chapters, mainly we have to find out potential at any point due to a single charge or due to some dipole or some number of charges, and you have to find out the work done in moving a charge from here to there. Okay, or capacitors problems. So the first question is always coming from first two chapters, and second question is always comes from current electricity, and third question is from alternating current chapter, AC chapters, and that is also very important. And for midterm exam, the fourth question is always coming from ray optics. Only for this midterm exam, the fourth question is from ray optics. For annual exam, there are some other chapters like dual nature or atoms or nuclei chapter is also there. So for coming midterm exam, so the fourth question is from ray optics. And the students' pattern has been changed. So you here there are only 45 questions, and in numericals, the last main, you are observing that only 4 numericals are given and you have to answer 2. You should answer only 2 numericals out of 4 questions. Okay. Yes, we'll solve the first numerical, that is calculate the potential at point P due to charge of 400 nanocoulomb located 9 centimeter away. So the first question is, here we are having one charge. Okay, the charge is Q, which is 400 nanocoulomb, and it produces electric field everywhere, and there is a potential also, right? So each point is having potential. We need to find out potential at point P, so which is at a distance R, right? So the distance 9 centimeter, R is 9 centimeter. So first thing is, always you have to write given. What is given? Charge is given, which is 400 nanocoulomb. So it is better to write 400 nano is 10 to the power minus 9 coulomb. Now you write it as 4 into 10 to the power minus 9 plus 2. 100 is plus 2. Minus 9 plus 2 is minus 7. Okay. This is Q. And distance R is given as 9 centimeter. You convert that to SI unit, 9 into 10 to the power minus 2 meter. Now use a formula, potential V can be written as 1 by 4 pi epsilon naught source divided by the distance. How to remember this? Constant into source by the distance. The point is at a distance R from the source by the distance. So this 1 by 4 pi epsilon naught is 9 into 10 to the power 9, and source charge is 4 into 10 to the power minus 7, and distance is 9 into 10 to the power minus 2. 9 number cancels and remaining is 4 into powers are 9 minus 7 becomes 2, and when this minus 2, when it comes to numerator, it becomes plus 2. So therefore the answer is 4 into 10 power 4. 4 into 10 to the power 4 volt. This can also be written as 4 into, see here, 10 to the power 3 volt, and 110, let us write here, that is 40. So what is this? 40, 10 to the power 3 is called as kilo. 40 kilovolt. This is the answer. And second one, obtain the work done in moving a charge of 2 nanocoulomb from infinity to that point. So infinity is somewhere here. Okay, so that means you are bringing a charge from infinity to this point. So infinity means it is a point where the potential is 0. So here this point is having 40 kilovolt of potential. You are bringing the charge 2 nanocoulomb from infinity to this point. So here what happens? This charge produces electric field, right? And therefore because of electric field, it is not easy to bring any other charge towards this because it always repels, right? So this charge, source charge, repels any other charges, right? So there is a force of repulsion, electrostatic force of repulsion. So it is not easy to bring a charge towards this. So some work is required against the electric field of source charge. So how to calculate work done? Work done is equal to the charge you are bringing. Okay. So let us consider this charge is Q1. What is Q1? It is a charge given 2 nanocoulomb. So you can write any symbol, okay, Q1 into potential at this point. Potential at this point. So that is Q1 is 2 nanocoulomb 10 to the power minus 9 into potential at that point is 40 kilovolt. 40 kilovolt 10 to the power 3. Or you can also write this number 4 into 10 to the power 4. 4 into 10 to the power 4. So 4 2s are 8 into 10 to the power minus 9 plus 4 is minus 5. And work done is expressed in joule. 8 into 10 to the power minus 5 joule is our answer. So this is potential and this is a work done. So here this carries 1 mark for the formula, 1 mark for the answer, 2 mark for this. Similarly 1 mark for the formula and 1 mark for the answer. 2 marks, 2 plus 2 is 4 mark. Right? Now there is one more question. Don't forget to answer this question. Sometimes you are not observing this third question, right? So don't do like that. So here, does this answer depend on the path along which charge is moved? See here, when the charged particle is moving from this charge, 2 nanocoulomb is moving from infinite to the given point against the electric field, whatever may be the path it follows, okay, it is moving like this to this point, or it will move like this and it finally comes to this point, or directly it comes to this point, whatever may be the path followed. Okay, so here this answer does not depends on the path followed. So it depends only on where it was initially, where it goes to finally. It depends only on initial point and final point. So here we can also write this as Q1 into V infinity minus Vp, potential at point P. V infinity is 0, final minus, this is Vp minus V infinity. So this is a potential at final point minus potential at initial point. Where it was initially, it is the charged particle is initially at infinity, when the potential is 0. V infinity is 0. The potential at point P is 40 kilovolt. So when charge is moving from lower potential to higher potential, some work is required to bring it, right, against the electric field. That's why, so work can be calculated like this. The charge which we are moving into difference in potential. Final potential minus initial potential, right? So like this. And does the answer depends? No, it does not depends on the path. It depends only on the points, initial and final points. Is it clear? Yes. Now the next question is, in the following network, find the current I3. So the network is like this. Here, current from battery is 1 ampere. As it comes to this point, it will divide it into two branches. See, I1 ampere of current is flowing through this branch, I2 is flowing through this branch. So we can write I1 plus I2 is equal to 1 ampere. So if you apply KCL at this node, okay, at some node. So here current entering is equal to current leaving. So which current enters? 1 ampere of current is entering, that is equal to sum of current leaving. sum of current entering is equal to sum of current leaving. So that is I1 and I2 are leaving. So therefore I1 plus I2 is equal to 1. Or we can write I2 is equal to 1 minus I1. Okay. So I2 is 1 minus I1. Now I1 is flowing through this branch. Okay. In this branch AB, I1 is flowing. And as it comes to this point B, out of I1, some current is flowing through this and remaining is flowing like this. Here it is mentioned that I3. Then what is the remaining current? I1 minus I3. I1 minus I3 flows through this branch. Similarly here, I2 is flowing here, and when it comes to this point, so here I2 is entering, I3 is also entering. So then what is the total current flows through this? It is I2 plus I3. I2 plus I3 is flowing through this branch. Is this clear, student? Now, let us apply KVL. So, what is KVL? So, first you have to take one loop while applying KVL, and you have to know down the traverse of the network. So, let us consider this is a way we are traversing the network, clockwise or anti-clockwise. You can either move in clockwise or in anti-clockwise direction. Then sum of EMF in that mesh or in this loop is equal to sum of IR. Summation IR is equal to summation EMF is called as KVL. So here we need to multiply current and resistance, and when you are traversing the network, then if current is along same direction, then IR product is taken as positive. Okay, let us use that rule. First let us apply KVL in this loop. So applying KVL to this loop, KVL to the loop, the first loop is A, B, E, F, A. A, B, E, F, A. So here which current is flowing? I1. So that is 10 times I1. 10 into I1. See here current and the network. See we are traversing the network in this direction. Current is also along same direction. So it is positive. Then we are going down. So here current is also going down. So therefore we are moving from A to B. Then branch is BE. BE. So current is also flowing same direction. So IR product is positive. So what is that product? 5I3. 5 times I3. Then we are moving EF. E to F. E to F. So current is flowing in this branch. Which current is flowing? I2, which is opposite direction. So IR product is negative. So that is 20 times I2. 20 I2. Okay. And we'll come back to same FA. So that here there is no resistor, right? So therefore that is equal to, so is there any battery here? Is there any cell? No. Therefore EMF is, there is no EMF, so it is 0. It is 0. Let us simplify it further because I2 is 1 minus I1. So 10 I1 plus 5 I3 minus 20 into I2 is 1 minus I1. 1 minus I1. So therefore we can write minus of minus is plus. 20 I1 plus 10 I1 is 30 I1 plus 5 I3. See minus 20 which comes to this side and it is plus 20. Now you can divide this by 5. So 5 6 plus I3 is equal to 4. Call this as equation 1. Similarly, let us consider the second loop, and I'll traverse the network in clockwise direction. So the loop, let us apply KVL to loop or mesh. Which loop? B, C, D, E, B. B to C, that is the first branch. C to D is the second branch. D to E is a third branch. Again E to B, fourth branch. Okay. So first branch here, which current is flowing here? Here it is mentioned I1 minus I3. I1 minus I3 into the resistor, which is 10. Okay. And we are moving along same direction, so it is positive. It is clear? Product is positive. Then we are going down. So here there is no resistor. Next we are moving in this way. So current is in opposite direction. So IR product is negative. Which current? I2 plus I3. I2 plus I3 and 5. I2 plus I3. And then we are moving up, current is in down, so minus 5I3 is once again it is equal to 0. Now let us simplify by writing I2 as 1 minus I1. Here let us write I2 as 1 minus I1. So I1 minus I3 into 10 minus 5. I2 is 1 minus I1 plus I3 minus 5I3 is equal to 0. So to simplify it further, first let us write I1 terms together. So here minus into minus is plus 5I1 plus 10I1, it is 15I1. And minus 10I3 and here minus 5I3 minus 15 and minus 5, that is minus 20I3. Minus 10, minus 5, 15, minus 5, minus 20I3. And 5 into 1 is 5. So minus 5 will comes this side, it becomes plus 5. So simplify it further, divided by 5 on both sides. So that is 3I1 minus 4I3 is equal to 1. Call it as equation 2. Is this clear? Now, so here we have two equation and two variables. So we need to simplify it further to get the answer for one variable, right? So two variables and two equation. How to simplify it further? So now let us multiply here by 2. Okay, multiply equation 2 by 2. That is 6I1 minus 8I3 is equal to 2. And add equation 1. Equation 1 is 6I1 plus I3 is equal to 4. So now you see here you have to write minus. This is minus, minus. Okay. So plus and minus. When you are adding plus and minus, it get cancels. Plus 6I1 minus 6I1 cancels. And minus means you have to add minus 9I3. That is equal to plus 2 minus 4 is minus 2. Minus 2. Therefore, I3 is equal to 2 by 9. 2 by 9. So, I3 is 0.22 ampere. 0.22 ampere. I3 is 0.22 ampere. Is this clear, student? The third question is like this. An AC source of frequency 50 Hz is connected in series with an inductor of 1 Henry, a capacitor of 90 microfarad and resistor of 100 ohm. Does the current leads or lags the voltage? Calculate the phase difference between current and voltage. So, first let us write the given data. AC source of frequency 50 Hz is connected in series with inductor 1 Henry, capacitance of capacitor 90 microfarad and resistance of the resistor is 100 ohm. So, to find does the current leads or lags the voltage? So, it is enough if you calculate XL and XC. XL and XC. See, let us consider the phasor diagram first. So, we have studied phasor diagram, right? If voltage and current are in phase, that is happens only in case of resistor circuit. In pure resistive circuit, current and voltage are in phase, right? So, in case of inductor circuit, voltage is leading. Voltage is leading the current. So, here there is a current. Voltage is leading in case of inductor circuit. So, in inductor circuit, voltage is leading, current is lagging, right? I'll write current I lakhs, lakhs voltage. Okay. In capacitor circuit, in capacitor circuit, current leads, current leads the voltage. So here we are having VC. Okay. This is VL. VL. Okay. Now, so how to find? Say we know that VL is equal to current into XL, right? VL is IXL. Similarly, VC is I into XC. So if XL is greater than XC, that means if XL is greater than XC, XL means VL. VL is greater than VC. Then we come to know that so current is lagging. Inductor circuit. See, VL is greater than VC means current is lagging the voltage. Is this clear? If XL is greater than XC means I lags. Okay. If XC is greater than XL, then I leads. Is it clear? Okay. Now let us calculate XL. XL is omega L, that is 2 pi f L. Okay. So that is 2 into 3.14 into 50 into 1. That is 2 into 50 is 100. 100 into 3 is 300. 314. Is this clear? 2 into 50, 100. 100 into 3 is 300. 314 ohm. Okay, XL. How to find out XC? It is 1 over omega C. That is 1 by 2 pi f into C. 1 by 2 pi is 3.14. F is 50 into C is 90 micro. Micro is 10 to the power minus 6. So XC is equal to 10 to the power minus 6 comes to numerator plus 6. And if you multiply 2 into 50 it is 100. 100 into 3.14 is 314. 314 into 90 becomes 28260. And if you divide this 1 divided by 28260, you multiply that with 10 to the power 6, you will get 35.38. 35.38 ohm. Okay. 35.38 ohm. So from this calculation we came to know that XL is greater than XC. Therefore current is lagging the voltage. Okay. So the question is, does the current leads or lags the voltage? What is the answer? Current lags. The answer is current lags the voltage. Current lags the voltage. Because XL is greater than XC or XL is greater means VL is greater. So VL is greater means, so here we are writing VL along y-axis, positive y-axis. It is, see, this is a rotating vector. Phasor is a rotating vector which is rotating in anti-clockwise direction. Our current is along x-axis, whereas VL is along y-axis means here it is already leading. Voltage is leading, right? Voltage is ahead of current. So voltage is leading the current, or in terms of current, current lags the voltage. Now the second question is calculate phase difference between current and voltage. So how to calculate phase difference? So now let us consider VL and VC are in opposite direction, means here the resultant of VL and VC is VL minus VC, right? So VL minus VC is somewhere here you will get, right? Correct? Huh? So for example, VL is 10 volt. Okay, example. VL is 10 volt. VC is, let us consider 3 volt. So they are in opposite direction. Then what is the resultant? 10 minus 3, 7. 7 is along this direction, right? So somewhere here we are having this resultant of VL and VC. Now add these two, V and VL minus VC. This is VR. Okay, add this. So you have to construct one parallelogram, and resultant is acting along the diagonal of the parallelogram, right? It is acting along the diagonal of parallelogram. So this is a resultant V. So it makes certain angle which is phi. What is phi? Phi is a phase difference between voltage and current. Then how to calculate phase difference? Tan phi is equal to opposite by adjacent. So which is opposite? This one. That is VL minus VC divided by adjacent is VR. So VL is IXL, VC is IXC, VR is IR. I is common, remove that. This is XL minus XC divided by R. So substituting, XL is 314 minus XC is 35.38 minus divided by R is 100, and it is tan phi is equal to, if you calculate this, you'll get 2.7862, and use tangent table. You have to check in tangent table 2.7862. That means in tangent table, second column, you check this number 7862, and in first column, the first letter, first number should be 2. Okay, integer should be 2. So check that number 7862, and you will come to know that it is 70 degree. So phi is equal to 70.24 degree. Okay. Now the next question is, an equilateral prism is made of glass of no unknown refractive index. A parallel beam of light is incident on face of the prism. The angle of minimum deviation is 40 degree. Find the refractive index of the material of the prism. If the prism is placed in water of refractive index 1.33, find the new angle of minimum deviation of parallel beam of light. So equilateral prism is having, equilateral prism means its angle of prism A is 60 degree. That is the first point you have to remember. Angle of prism or refracting angle is 60 degree. Here, a parallel beam of light is incident on one face of the prism. Okay. The angle of minimum deviation is 40 degree. D is given as 40 degree. Find the refractive index of the prism. Refractive index. What is the formula to calculate refractive index? It is sin A plus D by 2 by sin A by 2. So refractive index is sin of A plus D, that is 60 plus 40 is 100 by 2 divided by 60 by 2, which is 30 degree. So sin 50 divided by sin 30 degree. So in natural sine table, you have to check sine of 50 degree. So open natural sine table and go through 50. See here, 50th row, the number, 4-digit number you can see under the column 0 degree. You check that and write divided by sine 30 is 0.5. 0.7660 divided by 0.5. Sine 30 is half, right? 0.5. So which is equal to 1.532. 1.532 is the answer. So n is equal to 1.532. So refractive index has no unit. Okay, there is no SI unit, no dimension, no unit for refractive index. The sub question is, if the prism is placed in water of refractive index 1.33, find new angle of minimum deviation. So here it is placed in air medium. Then we are writing refractive index like this, right? So what is this is called as absolute refractive index. Refractive index of glass when the surrounding medium is A. How to write? NGA. Or this is refractive index of glass with respect to refractive index of air medium, NA. So this is called as absolute refractive index, Ng by Na, where Na is 1. So Ng by 1 is nothing but Ng, or simply we are writing it as N. It is understood that N is a refractive index of the glass prism. Okay, so we came to know it as 1.532. Now, if this is placed in water medium, here the surrounding medium is water, then how to write refractive index of glass with respect to water? It is Ng by Nw. Ng by Nw. So here refractive index of glass with respect to water is Ng by Nw. But what is the formula for refractive index? Sine of A plus D by 2 by sine A by 2, right? But here it is given that when you replace this air by water medium, then minimum deviation changes. So let us write it as d dash. Okay, minimum deviation changes, d dash. So therefore here let us write Ng is 1 point, just we calculated 1.532. Nw is refractive index of water, which is 1.33, and sine of 60 degree plus d dash by 2. Sine 60 by 2, which is 30 degree. Now let us cross multiply 1.532 divided by 1.33 into cross multiply. Sine 30 comes here. Sine 30 degree, that is equal to sine of 60 degree plus d dash by 2. So now let us calculate this. 1.532 by 1.33 into, first I will calculate this. 1.532 divided by 1.33 is 1.15. I'll get the number 1.151879 into sine 30 is 0.5. So I'll write 1.151879 into 0.5 is 0.5759. Let us write only 4-digit number. Sine of, so here also you have to write this, sine of 60 degree plus d dash by 2. So now how to do next? So here you write sine inverse of this number 0.5759 is equal to 60 degree plus d dash by 2. So now you calculate inverse of sine inverse of this number. Sine inverse of this number, let us calculate sine inverse of the number. So sine inverse of 0.5759 is 35 degree. So 35.16 is there. Now let us, after calculating the sine inverse, how to check that in table? You go through sine table, in that you check this number 0.5759. Okay, so you'll get 5759 in the table. Then corresponding angles in degree and minute, or you can write in degree. Okay, corresponding row you have to check. Okay, and column, adding you'll get this number 35.16 into 2. So that is equal to 60 degree plus d dash. So now multiply this. This is 70.32 is equal to 60 degree plus d dash. Then subtract, d dash is equal to 70.32 minus 60, which is 10.32 degree. 10.32, d dash is 10.32 degree, like this. So prism formula, applying prism formula, we can calculate refractive index. And here if I replace this air by water medium, then how to write? Refractive index of glass with respect to water. Okay, so refractive index changes, and this is a way of calculating minimum deviation. Is it clear? So like this, I have solved all 4 questions of model paper 1. So you can observe here that the first question is from first chapter or second chapter, and second question is usually from current electricity, and third is from alternating current, and fourth is from ray optics. So for this midterm exam, these are the chapters you have to get ready. Okay, so you need to answer only 2 questions. So if you are thorough with these questions, so if you know if the answer is perfect, okay, then no need of writing the extra questions, otherwise write extra. Okay, so suppose if you are getting confused with the answers you wrote, so then write extra questions, or it is always advised to write extra questions. If there is a time, then write extra questions. Thanks for watching.